Hello and welcome to my video on differentiating cos x and sin x. The first derivative of sin x can be written as d sin x over dx. This represents a small difference in sin x over the corresponding difference in x. In other words, this approximates a slope at a particular point. The first derivative can also be represented by the notation f dash x. The obvious first step is to use a general method to find the derivative of a function. The limit notation used here implies that h tends to 0. However, we can see that it is difficult to simplify in this form. At this point, you may be tempted to expand sin x plus h, but by doing so, you'll find that you run into the same problem. Can you think of any other way that this can be written? So you can rewrite this using this trigonometric identity. Now, it's your job to use this identity and simplify. You should have been able to get the derivative in this form. From here, we can use the fact that h tends to 0 in order to simplify and divide. We can also use the fact that h tends to 0 to show that the limit of sin h is equal to h. Thinking about the unit circle for very small angles of theta will convince you of this. So using this, we can simplify the derivative to a point where it can be divided by h. Now, all that's left is cos x plus 1/2 h, which of course is equal to cos x as h tends to 0. And we're done. Now, you should be able to find the derivative of cos x on your own. If you've done that, then try predicting the second derivative of sin x. The second derivative is just the derivative of the first derivative. A useful application of calculus is in physics. It's one of the reasons calculus was invented. Here's something to think about. No calculations required. The displacement of a pendulum undergoing simple harmonic motion is a function of time. At a certain time t, the first derivative of this function is 0. What is its velocity at t? And what does the second derivative of this function represent? If you're confused, thinking about the derivative as the slope of a displacement time graph will help. Thank you for watching, and see you next time.